Hi, everyone. Thank you for joining our webinar today on tooling for the manufacturing floor or the factory floor. We're going to be starting this webinar in 5 minutes, so please stay tuned while others come in. Hi, everyone. Thank you for joining. We still have people coming into the webinar, but we will be starting in 4 minutes, so please stay tuned. Hi, everyone. Thank you for joining us today at the Stratasys webinar around tooling for the factory floor. Our webinar will start in 2 minutes. Please stay tuned. Hi, everyone. Thank you for joining our webinar today on tooling for the factory floor. Comes to you today from Stratasys. Please stay tuned. Our webinar will start in 1 minute. Okay, hello everyone. Thank you for joining us today. My name is Ben Darling, and I am the Territory Manager for Stratasys here in Australia, plus New Zealand. Thank you for your time today. It is much appreciated. We know that time is very valuable. Today, we're coming to you with a webinar that is solely and wholly focused on tooling for the factory floor. This webinar is the 6th webinar in an 8-part series. So if you've not seen the other 5 webinars, please just put into the questions. Please send me a link to the past webinars. We'll be happy to accommodate and get those other webinars off to you so that you can view the content that was created over the course of 2021. Next slide. So just a couple of housekeeping items, or specifically one housekeeping item. I said where you could put, just please send me a link to the webinars into the questions area. That's what you see in front of you. On the slide is the area of the GoToWebinar user interface that allows you to either ask a question or ask us for something or content that we may have available. So very straightforward. We request that if you have a question throughout the webinar, that you just place it straight in that field, and then either at the end of the webinar, during the webinar, or according to how many questions we get, it could be even after the webinar, somebody will make sure that they contact you via email and answer your question. But we're going to endeavor to answer all of your questions before we come off of the webinar today, but we will have a hard stop in 1 hour. Next slide, please. So just a couple of minutes, or maybe even just a minute, on Stratasys. Stratasys is one of the pioneers in additive manufacturing industry. We have more than 140,000 installations around the globe, and we have more than 30 awards in the AM industry. And today, we are the world's most widely used 3D print brand, especially in manufacturing and for tool making. Next slide, please. Before I turn over to Stefan, if you could turn on your camera, but before I turn over to him, let me share some highlights of Stefan's background. Stefan has been in the additive manufacturing for many years, well over 20 years. He's also an award-winning additive manufacturing professional, and he won a best practice award from Ford for quality inspection fixtures. He now serves as the regional general manager for our manufacturing business unit here in our region. Plus, he's the general manager for Additive Flight Solutions, which is a joint venture between Stratasys and Singapore Airlines, where on a daily basis, Stefan and his team actually produce end-use parts and lots of tools for manufacturing floors around the globe. So, Stefan, welcome to our webinar, and thank you for agreeing to come in and speak to us today around factory floor tooling.
Great, thanks, Ben. I think I have nothing to add to this introduction. Thanks a lot. Let's go straight into the topic. As Ben mentioned, please raise a question. If it fits, we will try to put it inside the slide. So let's go straight to manufacturing trends. I think we see today a few very important elements which makes it important to be mentioned here, actually. Number one is, of course, we are moving forwards to Industry 4.0. We try to go from a physical to a more digital inventory trend, actually. Even though in a lot of SMEs, this is not happening so quickly, but we see on the growth on our request towards this technology, we see that the large multinational companies are moving more towards digital inventory rather than spending a lot of money in keeping parts on stock. I think we still have to mention this. COVID-19 is still not over. There are challenges in a post-pandemic time, actually, with supply chain. It is particularly difficult for countries like Singapore and Australia, where there's not every industry located, and where we are depending heavily on outsourcing as well as on supply chain. Another one is metal part replacement. We see a lot of movements to try to exchange metal parts against polymer parts, simply because of weight, cost, manufacturing time, and others. Health and safety in factories, also a very important topic. You can imagine an aluminum tool compared to a 3D printed polymer tool is most of the time double the weight. This is having the workers in mind, very important topic. I think we have also one slide showing a very nice application on the health side. And of course, automation and robotics. And here in particular, we see a huge potential. And I think we show a couple of examples. Weight reduction on end of arm tooling means half the weight, means increased speed. Increased speed means faster cycle times. Faster cycle times is bringing more profit to the companies. Okay, just let's talk 5 minutes about Stratasys. Stratasys is by today now the company which can offer the widest portfolio of 3D printing technologies. You have seen maybe the recent announcement. We took over 2 additional companies. And by today, we can offer PolyJet, which is famous. I think everyone knows them in regards of full color printing. Recently, there are some tests with the Fraunhofer Institute in Europe, really printing eyeballs so realistic that you can't see really the difference anymore. We recently added RPS. It's a company which is producing stereolithography printers. We are focusing with these printers clearly on investment casting and of course large prototypes with very fine details and high accuracy. The FDM portfolio is pretty well known. I think Stratasys 30 years ago developed this technology, and we today talk mainly about manufacturing of floor type production machine, not the small engineering machines. We added lately Origin, which is a DLP technology, very interesting, especially when it comes to large scale manufacturing, especially when it comes to very fine detailing. DLP technology will also be introduced to aviation. There are materials which fulfill all the requirements of FST, as well as have been approved already by major aviation OEMs. And the last one, which is quite interesting, again, that's our new H350 with the SAF technology, which is called Selective Absorption Fusion. And this is our new powder bed solution, which is targeting really serial manufacturing part production above 10,000 parts a year, which we put into the place today, actually, and we are happy to announce that we have been able to win major contracts already with customers who are changing over to Stratasys powder bed technologies. Obviously, as important as the hardware is, the software plays a vital role. And I'm also happy to see that, especially in the last 2-3 years, Stratasys has integrated all the printers as well as other OEM printers into the GrabCAD environment. And today with GrabCAD Shop, we have a complete tool which manages all your printers from a centralized location. Plus, we are offering GrabCAD SDKs, which allows other software companies to write parts for to join them with GrabCAD. This is, for example, relevant when you want to integrate GrabCAD into your ERP or your PLM system. So we have by today already a growing number of software development partners. There will be quite some announcements this year still, but let's wait until the time is right. Good. Let us quickly look at the application technologies. As I mentioned before, we really classify jetting or polyjet more on the design phase. It's fast, it's very accurate actually, and it's of course very colorful, but this is really more for high definition prototyping. While when we move over to engineering side, we go into FFF filament printers. Here we find mainly our MakerBots, our entry engineering technology printers. You're going over to manufacturing, and of course here the strategies, especially the F450, the F900, but also the new F770, which can print up to 1 meter in length, which is a large volume. These printers make, especially for printing of large components, very, very interesting. And then the DLP and SAF technologies clearly is aiming for serial production. We are quite happy that we have already customers who are producing or intend to produce more than 20,000 parts a year. And for these gentlemen, the SAF technology is the right machine. All right, let's discuss today mainly about shop floor. And here I would like to concentrate on FDM technology. If you have questions regarding DLP or SAF, the new H350, I believe Ben is more than happy to send over some more information. Why FDM? It's very straightforward. It's about a few very important points. It's impact strength and heat resistance. Impact resistance. For example, for the nylon 12 carbon fiber, which we are using on the 450 and 900s, this is fantastic if you compare it, for example, an SLA, which is far too brittle. We have with the nylon 12 carbon fiber the best mechanical properties, which is more than 25% stronger and 100% greater stiffness compared, for example, to SLS. It's easy to use. Whenever you see a company producing powder bed machine, you have special environments, you have powder spill all over the place. This requires much more attention to the setting. An FDM machine you can put into the corner, plug in the power and internet connection, and then off you go. Return of investment. This is typically for our printers between 9 to 18 months based on the machine type. For example, we have here in Singapore also an F900. Investment, of course, is huge. We have to print a lot of parts. So here we are aiming for around about below 24 months return of investment. Our printers are also producing certified. That's what we are doing here in Singapore. We are producing certified parts with certified material. For example, Ultim 9085, but also Antero 840 CN are approved certified materials for different business segments like aviation, but also rail, public transportation, and of course we have with Ultim 1010 also medical approved material. But what's much more important is you have one printer which can cover multiple applications. A quick one on the nylon carbon fiber again, because this is very often my choice of material when I come to shop floor tooling. We have right now, or by today, the best in-class carbon fiber reinforced thermoplastic. We have a much higher density, up to 99%. We have 35% chopped carbon fiber placements. We are achieving almost a 90% isotropy consistency. And we have with 135 joule per meter, actually a fantastic impact resistant. I think here a very important point is that a 3D printed part is not always benefiting from continuous fiber. It is the complete printed element actually. And here you can see an example from one of our customers, Abigail Bedley, and they are trying to load a part with weights. And you see 3 lines here. We have a continuous carbon fiber part, which fails at round about, I have to look, 16, 17 kilo. The orange line is the Stratasys 12 nylon 12 carbon fiber, and then the gray one is the aluminum 6082 Temper 6, which is a pretty typical tooling aluminum material actually, and the nylon 12 carbon fiber is coming much closer to this application. It is for a logistic company, it's a hook which has to take impacts as well as, of course, pulls a lot of weights. I just want to introduce you quickly to one of the machines, FDM, which is our new F770, which is a shop floor printer. It's mainly focusing on two materials at the moment, on ASA as well as ABS. And it is a very pricely sensitive place printer, very economical, large print format, up to 1 meter by 600 by 600. And a very important message, you can make small parts on a big printer, but you cannot make big parts on a small one. So bear this in mind when you think about to invest in a smaller printer. The price difference to this long printer of 1 meter is not as big as you might think. Bennett, I think, more than happy to give additional pricing information on that. Let's go back straight to challenges for the factory floor. I'm concentrating on a few topics: prototyping, spare parts, metal replacement. So the typical challenges today are high cost. Obviously, metal produced part. We have done several comparisons, and we see very often that if you machine a prototype out of an epoxy block material or out of aluminum, for example, both, we achieve sometimes up to 98% cost reduction by just printing the part you need. We have a nice example I'll show you later on. This can be printed during the coffee break. It's 30 minutes and then the part is available. Try this on a milling machine. Another point is lead time, of course. I just mentioned it. You print when you require the parts. We see today also a lot of 3D printers without heated chambers. You have a less consistent bonding between the different layers, and this is, of course, leading to failures in products. So unreliable printers is today also a threat or a challenge. And as I mentioned before, supply chain to me is always an extra point, especially since the last 2 years. I don't know how you see it actually, but to me this is has been a nightmare at several locations when you're really looking for or waiting for part deliveries from different locations. 3D printing makes it possible to print on demand, and we are changing also here in Singapore more towards local manufacturing. So opportunities with our technologies is great. Lower cost. We promise, and I think this is really, it's a really promise. We can reduce cost on a lot of applications between 60 to 95%. I have enough examples. I will show some later on. Fast turnaround. Typically, lead time reduction from 50 to 90% is possible because you print on demand, you print on the spot, you print at your site. So you print when you need. Shipping cost saving, obviously, I don't have to mention this. Print in-house, it's available on the spot. And of course, I think one of the very important points, and we see this every year in our customer satisfaction reports, the reliability of our technology with dedicated service engineers at your hand is a very important step towards reliable manufacturing. As you can imagine here, we produce aviation parts. I cannot allow a machine breakdown for 1 or 2 days just because of a fan is not working. So we need, first of all, the service, but foremost, I need reliable printers. Okay, opportunities on the factory floor. Typical factory floor, and we do this really very, very frequently with aviation customers as well as other industry customers. When we are going on a factory walk, we find an average 30 applications we would like to prove the customer that, look, print the tool and we promise you we have a cheaper product, less cost, and a more reliable tool. Some are, of course, in assembly. We have parts in checking plug gauges. It's a very big topic and something where I spend a lot of time of my business life inside. R&D, tooling, development phases of a product. Obviously, this is one of the major prototyping steps. That's why 3D printing became so big. Obviously, we all agree that 3D printing replaced most of the conventional manufacturing methods in creating prototypes. We have quality control, jigs and fixtures, also one topic I really like. See, a measuring fixture is a one-time use application. It is produced only once, so 3D printing is the choice of manufacturing technology for measuring fixtures. Packaging logistic, fantastic application. What else we have? Health and safety. Oh yeah, we have a very nice example. I'm not sure if you can see the picture. This is the employee wearing an supported thumb on his right hand, which is avoiding health issues and, of course, injuries to the employee. Is increasing greatly safety and addresses economic issues. And of course, last, automation, end-of-arm tooling, definitely a very interesting topic. As I mentioned before, less weight means faster cycle time. Faster cycle time means more profit. The field is so big, I'm concentrating really today on 4 main topics. I'm talking about tooling and end-of-arm tooling. I'm talking about spare parts production, end-use parts. I'm talking about measuring fixtures on assembly jigs. And of course, I show some examples from the CNC sector. Because we produce more and more 5-axis produced components on our CNC milling machine, clamping is a very important and difficult issue here. So let's go to tooling and end-of-arm. This is a nice example from aviation. It is an aileron hinge bearing tooling. You see the hinge bearing tooling, which is normally having a metal bearing inside. And the customer required a tool to remove this bearing from the aluminum part without damaging the aluminum part. And yeah, the 3D printing was able to print a very simple tool, put it around the aluminum aileron part, and hammer out with an additional nylon carbon fiber 12 tool the bearing from the part and replace it with a new one. Fantastic example. It is very lightweighted. It addresses all the important ergonomics. And if I remember correctly, the tool was around 1,200 Australian dollar, and it was delivered within 48 hours. Very straightforward. Another parts for aviation are, for example, rivet shavers. All these tools you see here have been designed and developed by Boom Aviation. You know, the nice company who is trying to get supersonic back into the air. We have engine mountings, flight control parts. So you see not only tools, but you see also end-use tools. But especially the engine mount as well as the rivet shaver are production tool permanently in use. Protection covers, good example. This is one of this many parts we find during our shop floor. It's about really offering protection covers to special avionic cables and plugs. The original plug is priced at 60 Australian dollar, and a simple replacement tool with including locking mechanism costs $35. So you have a 42% cost reduction. To me, this is a no-brainer. And it's a proof that with design changes and an optimized component approach, we can beat conventional tooling at cost. Another very important application, of course, are grippers, and especially grippers in an environment which requires ABS ESD7 material. electrostatic deceptive materials. We have some more examples from Rico later on. It is, in my eyes, a fantastic application because grippers can be produced much lighter. You have optimized vacuum or air channels. Very often you combine multi-parts into one single component, which is also reducing storage, design, and maintenance cost. And of course, printed overnight, so availability is fast. Especially this multi-grippers, here again, weight is a crucial role, very important role. You need to reduce weight in order to run faster cycle times. Another one, this is from Rico, I just mentioned before. The anti-static materials play here a very important role. And we completely replaced most of the metal jigs with our thermoplastics. It is lightweighted and printed in days compared to 2 weeks for the outsourced metal jigs. And of course, it is more operator efficient. And because we can integrate much easier additional feature in aligning and placing the component into the jig and fixture. The same thing, of course, with additional grippers. These are not small parts. Here it's a good example of our ABS carbon fiber 10. It's a new material which is available for the MakerBot as well as the F123 series, which brings it to the 170, 270, and 370. Fantastic material. Nylon carbon fiber is still limited only to the 450s and the 900s. Fantastic application of TPU. I hope you can see this nice video running. This example in particular is so great because we really combined more than 20 components into two. No metal springs. We use a TPU spring and an ASA frame. Reduce maintenance costs, increase mean time between failure. We have been getting so much traction with this kind of application, combining TPU and ABS, including ABS ESD7. I think I have one more example later on showing. To me, this is a fantastic example of combining large number of components, including functionality. Another gripper also worked food packaging, pick and place gripper. You see here the number of parts. 20 parts are grabbed at the same time. Obviously, you can reduce probably this gripper even further by also changing the framework of the gripper towards 3D printing. For that exactly, you need the large format printer like the F770 or the F900. Here we are. Let's go over to spare parts, replacements of end-use components. Fantastic example here. This is an impeller replacement and including the housing. Again, the beauty was here, the customer replaced 22 components with a single item, resulting in 98% cost reduction. And this is not only possible by reducing the number of parts, but also by the complexity of the component. Again, integrated functionality. And this was a replacement part. So the customer is paying thousands to make a single replacement part, normally in metal. Again, make 22 components and assemble. This brings already down the cost. 22 parts into one. Nice example of spare parts and delivery on spot is the Siemens Mobility website. They have actually even created a web shop around their spare part sets, especially when it comes to replacement parts for their transportation line. As I said before, the F900, F44, for 450 are producing certified components. The web shop is there for customers. Log in, order your from bumper over other replacement parts, and most of them or many of them are 3D printed. So it's ordered on demand. Oh, nice case study from Caterpillar. Heavy duty tooling, checking fixtures, drill collets, assembly racks. Time here reduction possible of 40%. We have again more than what is this? A drill. Oh, so the drill collet was a different part again. It was due to the supply chain, received only in 4 weeks. Can be printed in 4 hours, especially on the F900s, where the print speed is really, compared to other printers, tremendously bigger. Spare parts, again here, also a nice example. We have a video as well here. Again, the weight of component is playing a vital role. Existing metal part was not working correctly. Replaced 3 times a month. As you can see here, reduction time, downtime is one of the big costing factors. Print a spare part on demand is printed within 50 minutes, which is resulting in 83% cost saving. And of course, for this company, a return of investment in less than 6 months. I think this is something what manufacturing planning engineers are really looking forward to. Measuring fixtures, that's a good example. Additive manufacturing can bring really inspection jigs up to speed. A good example are accurate scanning fixtures. That's for a fuel pipe check fixture. You just place a part inside. You can print and fine adjust these items up to an accuracy of plus minus 0.2 millimeter. If you need further accuracy, then there is also ways actually to do it, but this is standard, I would say, mechanical engineering ways. You are using shims and adjustment blocks if you need a better adjustment. Here we're combining a very large tool with a total length of above 1.4 meter. You have a huge frame made out of many components. You combine them into a 3D printed framework, and all your end contact points are shimmed, doweled, and of course then screwed, and before that measured to accuracy. So you can achieve much better accuracies. I have been selling these kind of checking fixtures before for many years. And in the automotive industry, surface contacts have an accuracy of plus minus 0.1, and master location points will require plus minus 0.05 millimeter. This can only be achieved if you can fine adjust those location points. This cannot be printed still today. CNC fixtures, again, one of these applications which is really a burden, and whoever actually tried to clamp a 3D shaped component onto a milling machine and into a vise knows what I'm talking about. We have today great applications from different customers printing 3D shaped components in order to replace the standard jaws with 3D printed jaws. The nylon carbon fiber can withstand huge hydraulic vices, clamping forces. So you can really clamp and secure the part on your milling machine, also for heavy milling application. And a very important message, you print the jig away from your expensive CNC milling machine. I think this is one of the most important assets. Another one here, metal parts replacements with nylon carbon fiber, holding small steel parts during grinding. We have additional samples, which I always like. when it comes to very complex casting components, which need a fine finishing at the end. Holding this kind of components without deformation is always a challenge. And obviously, 3D printing can play here a very fast role. And this brings me to one of our nice customers, and I think his statement is so true. It's a small $10,000 printer which keeps $1 million machine running through automation. It is the right tool to move fixturing away from the milling machine instead of producing it on a very expensive milling machine, move it towards an entry FFF printer like the MakerBot. And I would like to show a small video about this one. And sorry.
We have these $1 million machines that are out there on the production floor, and right next to these machines we have a MakerBot method 3D printer that is about $6,000, and it's that $6,000 machine that is able to keep a $1 million machine running through automation. My name is Gary Kuzman, and I am the owner of All Access Machining and All Access Robotics, located in Dallas, Texas. We are a facility that makes custom parts for customers around the world in aerospace, defense, and commercial applications. For all owners, including myself, automation is a key to being productive and also profitable. You have to be both. And with the implementation of the automation we have in our shop, I'm actually able to reduce our hourly costs significantly to be competitive with other companies that outsource their products to be made overseas. With the MakerBot method 3D printer, we were up and running in about 1 to 2 days, and that's the simplicity of the operation.
My name is Dave Burkowski, and I'm the General Manager of All Access Robotics. So we require dimensional accuracy in order to be able to, let's say, build an end effector that's going to fit on the end of the robot. So we need precision within 0.004 of an inch. And we are incredibly satisfied with the MakerBot method, actual output from that location perspective. We have a high precision CMM to measure our MakerBot parts to make sure that the holes that we place into this part are within tolerances that we need. And lo and behold, we are very happy.
So my name is Christian Almendarez. I am an engineering manager here at All Access Machining. In a high-mix, low-volume shop like ours, it's having a MakerBot method has enabled us to be able to meet the wide variations of parts that we have. It's just the end effector for the robot it's a 3D printed sander. You have the 2 surfaces for 2 different grits, and then an attachment for a vacuum hose on there. So this sits on the robot, and the robot will go through and sand and vacuum at the same time. If I wanted to machine this, taking into consideration the tool cost, the time to program, and the time to set up the machine and run it, I'm looking at $3,000, $9,000. If I wanted to 3D print this with the MakerBot method, it costs us maybe $5 to $10.
There's a very large need to develop custom parts, and not all of this is possible by making them on a CNC machine. So when we purchased the MakerBot method 3D printer, we automatically obtained all that capability for customizing all these different parts that we need.
Which brings me, oops, sorry. Brings me to the end of our presentation today. Ben?
Yes, I'm here, Stefan. Thank you very much for your time. Look, we have had a few questions come in via the questions box, and I'd like to put them to both you and I guess. The first question is that they're asking, why would someone use nylon carbon fiber versus ABS carbon fiber?
Okay, the nylon carbon fiber, if you put the two data sheets next to each other, obviously the nylon carbon fiber still is stronger. But the nylon carbon fiber we are printing only on the F450, on the F900s, because you need a higher heated chamber. The ABS carbon fiber is the entry material, which is strong enough for most applications. As you have seen on the MakerBot video, actually can do a lot of jobs, but it maybe cannot do the final one. Let me just show a nylon carbon fiber tool here. Here we are.
Your video is paused. Your video is paused.
Stop my webcam, share my screen again.
There we go.
Yeah, 1 meter up. That's a window wiper alignment tool for the automotive industry, made in nylon carbon fiber. This kind of stiffness, this kind of length, you can only produce on this large scale format printer. I mentioned before, you can print small parts on a big printer, but to do that, you need an F900, of course. This is reducing the complexity and the number of components you need. And of course, the cost. I prefer to have a little bit more profit on selling these kind of jigs and fixtures rather than spending them in metal manufacturing.
That's a great part, big part actually, and is a testament to our Fortis 900 and Fortis 450. There was another question about what is the shore hardness of your TPU, and what machine does it come on?
TPU is actually on the 370s. If I remember correctly, we can still set different shore hardness, but I think the standard one was 70, if I remember correctly. You got me on my cold feet.
Got it. Stump the chump. That's what we did today. That's good. Best question of the day, by the way. Look, I can say that the TPU. I'll let Stefan look up the shore hardness, but TPU comes on our F370, and also to change sort of the flexibility, even though it doesn't change the shore hardness, you can actually build, because it is a extrusion or FDM process, you can build infills into the part so that it gives it a bit more flexibility where required. You can also, because you're using the software insight, you can put infills or solid areas in other parts so that you can then control or vary the flexibility across the part.
Shore hardness 92, scale A.
92 scale A, okay. And then what material has the highest heat resistance? And I think all we can really answer on this question is by our Stratasys materials. But what is our highest heat resistance material?
This will be today actually nylon Ultem 1010 for us actually. We are using this for plasma coating masking in the aviation industry. There we have to withstand over a certain period up to 200 degrees. Yeah, then Ultem 1010 is the only choice we have today.
Understand. Good. So Ultem 1010, and what we'll do is we'll send the spec out to this question afterwards. There's another question. What material is suitable for printing sand casting tooling, both the pattern and the core boxes?
That's a huge topic, which is difficult to answer in one question actually, or in one word actually. I think we have to look into, for example, sacrificial cores, which we can print with soluble material. We have a very nice example here with a customer who is building UAVs. And he has very often a very boxy main shaped container. And for this customer, we are printing soluble sacrificial cores. on the 450 and 900, even sometimes up to the size of 400 by 400 by 400, which are the compartment of this UAV printed in, which are made later on with composite materials, actually like carbon fiber, mats, and so on. Sand casting pattern are done very often with ABS materials, actually, but also with the PolyJet printers possible.
Yep. Last question. Yes, last question that we have is, what software do you use to slice your 3D printed parts?
Oh, that's easy one.
Basically,
we have two different software packages. We have Stratasys is having software called Insight, which is I would say the high-end professional expert software where you can tweak each and every slice to the limits. But we are moving more and more towards an end-user interface called GrabCAD Print. In GrabCAD Print, you can load in all your CAD formats. You don't have to have an STL format, actually, like many other software packages. You can import CATIA, SolidWorks, NX, and any other Creo, whatever, any other CAD file format you have. And you have then actually the capability of doing some quick tweaking. And you can apply textures, and then you can slice it for basically every machine you have from Stratasys. There are initiatives actually also implementing other printers, but right now, at least all the Stratasys portfolio printers can be addressed by GrabCAD Print. The GrabCAD Shop software is a software which can manage your planning and your manufacturing organization.
Yep. I think that's the last question, but great answer. I think if there's any further questions, you can certainly get in touch with myself. All you have to do is scan this QR code that you see on the slide, or just jot down my email address. Feel free to send me an email. And of course, someone will be in touch with each person that had a question after the webinar, and just to make sure that your question was answered as thoroughly as you like. So again, on behalf of Stratasys and everyone on the webinar, Stefan, thank you very much for the content. Very well done. We do appreciate your time today. Also, on behalf of Stratasys to all the attendees today, thank you for giving us your time today. We know that it's valuable, and we hope that it's been helpful to you. Again, please feel free to reach out to Stratasys or to me direct. We're always happy to engage customers with further questions or queries. I think with that, we can close the webinar. Thank you, everyone. Have a great day.